What's up, everyone? Welcome back. Patrick here. Moving on to the next question. So we are given a triangle that has the vertices A, which is at 8 and 4, B at 2 and -8, and then C at -4 and 7. And with that triangle, what we got to do is we got to find the centroid, the circumcenter, the orthocentre, and then in part D, once we have all three of those points, we have to show that they're all going to be collinear. So initially what I was going to do was I was going to make a separate video finding the centroid, finding the circumcenter, finding the orthocentre with different triangles, but I decided to combine them into one because I want to show you that for any triangle, all three of these points are all going to be collinear. And what collinear means, just as a quick overview, if 3 points are collinear, what it means is that all 3 points are going to lie on the same line. And when the centroid, the circumcenter, the orthocentre, the line that they all lie on, it's actually something called the Euler line, if you want to look that up. Okay, so for any triangle, the centroid, the circumcenter, the orthocentre, they're always going to be collinear. They're always going to lie on the same line. It doesn't have to look like that. It could be maybe like a negative sloped line. Sometimes they can actually be the same as well, some of these. So for example, for an equilateral triangle, the centroid, the circumcenter, the orthocentre, they're actually the same thing. Okay, and even if they're the same thing, that means that they are still collinear. Right, so an example of maybe 2 or 3 points that wouldn't be collinear is maybe if you got, let's say, 2 points like that, and then you have another point over here. Notice that you can't draw a line, one line that contains all 3 points, right? So if you draw a line over here, this point won't be on it. If you draw a line over here, then this point won't be on it. Okay, so for any triangle, all 3 of these, they're always going to be collinear. They're all going to lie on the same line. And that's why I wanted to combine them into one video here so I can show you that in part D. Now, just as a quick overview, what the centroid for any triangle is basically the intersection of all 3 medians. So if you draw a median from all 3 vertices, they're going to intersect at one point, and that point is going to be the centroid. The circumcenter of a triangle is going to be the intersection of all 3 right bisectors or perpendicular bisectors from each side, from each of the 3 sides of a triangle. And then the orthocentre is going to be the intersection of the 3 altitudes from all 3 vertices. Now, just to save time in this video, just because we're packing a lot in here, it's going to be quite a long video. Instead of finding all 3 medians, all 3 right bisectors, all 3 altitudes, we only need 2 to find the intersection points. So I'm actually only going to find 2 medians, 2 right bisectors, 2 altitudes. But if you want, what you can do is the median that we don't find from whichever vertice we're going to leave out, you can find it yourself, and then you can just verify that the centroid that we find, for example, is going to lie on that 3rd median. That circumcenter is going to lie on that 3rd right bisector, all right? So it's a little extra practice that you can do yourself, but in this particular video, just to save time, we're only going to be finding these with 2 of these respective lines. All right, so let's start off with part A. So what we're going to do is we're going to find the centroid. So let's actually draw a diagram of a triangle. This is not going to be to scale, right? If you were to draw it on a Cartesian plane, it might take a different shape, but I'm just going to draw a rough one here just so we have something to refer to. And then we got C, which is at -4. And 7. So really you can pick any 2 medians you want to work with. I'm going to pick the, let's start off with the median from C. So it's going to look like that, right? What is a median? Just as a review, it's basically the line from the vertex to the opposite midpoint of the opposite side. And then it doesn't matter which one. Let's do a median from A then. right? So it's going to be to the opposite midpoint over here. And so the centroid is going to end up being right there. There's actually a quick way to find the centroid as well, and I'll show you that way at the end. But most teachers, they're going to require you to find it by finding the intersection of the medians. So these are the medians that I'm personally going to work with, but as I mentioned, if you want extra practice yourself, you can find the median from vertex B as well. You can find that third median and then just verify that that centroid is on that line that you find. And the way you do that is you could take the x and y of that centroid, you could plug it into the equation of that third median you get, and you want to make sure that the left side is going to equal the right side. Okay, so let's find the median from, let's start off from vertex A. All right, so we have this point, 8 and 4, and what we need is we need this point over here. Let's call it M, right? So that's going to be the midpoint between B and C. So the midpoint of B and C, or this, this letter M here. What is the midpoint formula? It's x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if we label this x1, y1, x2, y2, what are we going to get here? So adding up the x values, we'll have 2 plus negative 4 divided by 2, and then we'll have negative 8 plus 7, and we're going to be dividing that by 2. So over here we'll have 2 minus 4, which would give us negative 2. That's going to be over 2. And then we'll have negative 8 plus 7, which is negative 1. And that's going to be over 2. And then negative 2 over 2, that simplifies into negative 1. And then negative 1 over 2, I'm just going to leave it as a fraction. So this point here is negative 1 over 2. So now we could find the equation of the line, right, that contains both of these points. So what we would do, we could start with the slope. So the slope is y2 minus y1 over x2 minus x1. So we'd have x1, y1, x2, y2. And then we'll have negative 1 over 2 minus 4 over negative 1 minus 8, like that. And then negative 1 over 2, let's do this on the side, minus 4. 4 is like over 1, so common denominator. Let's get 1 here, so negative 1 over 2 minus 8 over 2, which would give us negative 9 over 2. So this numerator here ends up being negative 9 over 2. And then this is going to end up being negative 9. Like that. So it's like we're taking negative 9 over 2 and dividing it by negative 9 or negative 9 over 1. So if we rewrite that, it's like negative 9 over 2 divided by negative 9 over 1, which is like negative 9 over 2 multiplied by 1 over negative 9. And that's nice because notice that the negative 9s will cancel out and we end up getting just 1 over 2. So the slope of this line is going to be 1 over 2, and then we'll have y equals mx plus b. So we'll have y equals 1 over 2 x plus b, and then we could plug in either point for x and y, solve for the b value. I'm going to plug in this point, so we'll have 4 for y, and then we'll have 8 for x, and then we end up with 4 equaling 1/2 times 8 is just 4. So the b value would be 0. Okay, so the equation of this median over here, so let's keep track of it here. So the median from A, the equation would be y equals 1 over 2x plus 0, but we don't have to write the 0. Right, so that's the equation of this median over here. Right, now what we got to do is we got to find the median from C, right? So from this vertex, so we already have one of the points, which is the point at C. We just now have to find this midpoint of the side A, B. So to do that, midpoint formula, what do? Well, we add up the x values, so let's label these x1, y1. I'll let this be x2, y2. So we would add up the x values divided by 2, add up the y values. That's a negative a, so be careful. You put that in brackets, divide by 2. So this would be a plus 2, which is 10, divided by 2, which gives you 5. And then 4 plus negative 8 is like 4 minus 8, which would give us negative 4. Over 2, that would give us negative 2, like that. Right, so this point over here is 5 and negative 2. Okay, so we basically have to find the equation of a line now going through these 2 points over here. So same process, let's find the slope. I'm going to let this be x1, y1, x2, y2. So the slope would be y2 minus y1, so we'll have negative 2 minus 7 over x2, 5 minus x1, negative 4. So just be careful with your signs here with your negatives and stuff. So negative 2 minus 7 gives us negative 9. 5 minus negative 4 is like 5 plus 4, which would give us positive 9. And so this would end up being negative 1. So the slope of this line is negative 1. So we'll have y equals negative 1x or negative x plus b. And then we could plug in either of these points, solve for the b value. Doesn't matter which one you plug in, you're going to get the same thing. Let's plug in this one. So we'll have negative 2 for y, and then we'll have positive 5 for x. So we'll have negative 2 equals negative 5 plus b. So b would be, when we bring the negative 5 over, negative 2 plus 5, which would give us 3. Right? So we have y equals negative x plus 3. So that's the equation of this median over there. Right? So we have now the equation of 2 medians. So we can now find the centroid. We can find the point of intersection between these lines. Right? So we can do substitution or elimination. What I'm going to do, because the y's are already isolated, let's just make them equal. Like that. Let's bring the negative x over, so we'll have 1 over 2x plus x equals 3. So over here, 1 over 2, let's do this on the side, plus 1, multiplied by 2 to get the same denominator. And this would end up being 3 over 2. So this here would end up being 3 over 2x equals 3. We can rewrite this. Let's combine these. So I'm going to rewrite them as 3x over 2 equals 3 over 1. Another thing you could do if you want, you could just divide both sides by 3 over 2 to get the x by itself. Either way, whichever way you do it, just make sure you're getting the same x value that I'm going to get. So 3x times 1 gives us 3x. 2 times 3 gives us 6. Divide both sides by 3. X would be 2. So the x value of this centroid here is 2. To get the corresponding y value, you can plug it in to either equation of the median, either this one or this one. Notice if I plug in 2 over here, negative 2 plus 3 is 1. 1 over 2 times 2 gives us 1 as well. So the y value is 1. And so that is the answer to part A. That is the centroid. It's going to be at 2 and 1, and let's actually keep track of it over here, because we're going to need all these points for part D to show that they're all collinear. So the centroid is at 2 and 1. Now, as I mentioned, if you want to find the median from vertex B, right, so you'd follow this exact same process, get the midpoint between A, C, whatever equation that's going to be, you just have to verify that that point is going to be on that equation. The way you do that you're going to get an equation y equals mx plus b, right? There's going to be some kind of m value, some kind of b value you get. And then all you have to do is you have to plug in 2 for x, and then just make sure that you get a y value of 1. Or you could plug in 2 for x and then y. You could plug in 1 for y and just make sure that the left side and the right side are equal. Then if they are equal, then you know that that point lies on that median. Remember, it's going to be the same point of intersection for all 3 medians. Now, one thing before we move on to the circumcenter, as I mentioned with the centroid, there's actually a quick way to solve the centroid in particular. What you can actually do is you can average out all of the vertices. So you can, the centroid is basically x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. Right? So with the centroid in particular, it's a nice quick way to check. There's also different formulas you could use for the circumcenter and the orthocentre, but they're more complex, right? They involve matrices and just tools from higher grades, so they take more time. But for the centroid in particular, it's really quick to just take the x values of the vertices. So notice 8 plus 2 plus -4. Let's see what happens when we divide that by 3. And then the average of the y value, so we'll have 4 plus -8 plus 7. What's going to happen when we divide that by 3? Well, notice we'd have 10 over here minus 4, which would give us 6 over 3. Then over here we'll have 4 plus -8, which is like 4 minus 8, so it'll be like -4 plus 7 gives us 3. And so notice we end up getting that same value. All right, so for the centroid, if you're asked to solve for it on a test, it's a nice quick way to check your work. Highly doubt your teacher's going to allow you to do this, to show your work like this. They're going to probably make you want to find the medians, maybe all 3 medians, but definitely 2 at least, then find the point of intersection between them. But this is just a nice way to quickly check your work. So now moving on to part B, we have to find the circumcenter, which is going to be the intersection of all 3 right bisectors. Now, how do you find a right bisector? Well, if you have the endpoints of a side, just as a review, it's basically the right bisector is going to be the line that goes through the middle, that bisects this line here, that bisects this side, and is perpendicular to that side. So again, all 3 right bisectors are going to go through that circumcenter, but we're only going to work with 2 of them. And notice that we already actually found the midpoint of side AB and BC in the last part. So I'm actually just going to use those midpoints. I'm going to create the right bisectors from both of those sides. So if we draw this out, it would look something like this, right? These are going to be the right bisectors here, where this and this are going to be perpendicular. So where they're going to intersect over here, that's going to be the circumcenter. And then if you created the right bisector from side AC, which you can do yourself if you want, you'd find the midpoint, then find the perpendicular line, you would notice that that line also is going to go through that same point that we're going to find. But again, we're just going to be working with these 2 over here. So let's start off with the right bisector of AB. So what's nice is that we already have that point 5 and -2, right? That it's going to contain, that right bisector is going to contain. But what we need is the slope of this line. So how can we get it? Well, notice we could find the slope of AB, and then whatever that slope's going to be, we take the negative reciprocal of that to get this slope. And then once we have that slope, we have this point, we could find the equation of that line. You could also, instead of using these 2 points, you could use these 2 points. You could also use these 2 points because they're all on the same line. So whichever combination of 2 points between A, this midpoint, and B you're going to use, you're going to get the same slope. I'm just going to use A and B, right? So that's x1, y1. I'm going to let this be x2, y2 over here. So let's first find the slope. Let's keep track here of what we're doing. So we're finding the slope of AB. We're finding the slope of this over here. So it would be y2. Let's actually write out the formula first. So we'll have y2, which is 4, minus y1, which is negative 8, right? So minus a negative there, over x2, which is 8, minus x1, which is 2. So we'd end up with 4 minus negative 8, which is like 4 plus 8, which would give us 12. 8 minus 2 is 6. That would be 2. Okay, so the slope of AB, of that side AB, is 2. But we don't need that slope, we need this slope. We need the perpendicular slope, so we would find the negative reciprocal of this, the perpendicular slope. So this is like 2 over 1, so if we flip it, it's 1 over 2, and then we change the sign. Notice this is a positive, so this would be a negative. So this slope here is negative 1 over 2. So let's write that over here. And now we just have to find the equation of a line that has this slope and that goes through that point. So we know how to do that. Plug in the slope first. And then we plug in negative 2 for y. Then we plug in 5 for x. This would end up being negative 5 over 2. This would end up being negative 2. Bring this over. So the b value would be negative 2 plus 5 over 2. This is like negative 2 over 1. Multiply by 2, multiply by 2 to get a common denominator. Negative 4 over 2 plus 5 over 2, which would give us 1 over 2, like that. So that ends up being the b value right here. So this would end up being 1 over 2. So that's the equation of this right bisector. Now you could also use, to find that b value, use the formula y minus y1 equals m bracket x minus x1. If you do use that, just make sure that you're getting this same equation over here. Right, so that's the right bisector of AB. So let's write it over here, because we're going to need it when we're finding the point of intersection, when we're going to find that circumcenter. So now let's find the right bisector of BC. So notice that we already have the point that it's going to go through, the negative 1, negative a half. What we need is the slope of it. And first we have to find the slope of BC over here. So we already have it labeled x2, y2, x1, y1. So let's first find the slope of BC, which would be y2, 7 minus y1, which is negative 8, x2, negative 4, minus 2. Just be careful with your algebra here. Let me do a quick check. 7 minus negative 8, and then negative 4 minus 2. Okay, so this would be 7 plus 8, right? The two negatives turn into a positive, which would give us 15, over negative 4 minus 2, which gives us negative 6. Right, we could bring the negative up, put it in a nicer format, and then notice we can actually simplify this. We could divide this by 3, divide this by 3, so we'd end up with negative 5 over 2. So that's the slope of BC, negative 5 over 2. But we need the perpendicular slope to that, so we would find the negative reciprocal of that. So we would flip that, 2 over 5, and then notice it's a negative here, so this would end up being a positive. Okay, so the slope of that right bisector of this line here is going to be positive 2 over 5, and it's going through that point, so now we can find the equation of the line. So let's erase all of this here. So we'd have what? Y equals 2 over 5x plus b, like that. Let's plug in negative 1 over 2 for y. Plug in -1 for x, right? Let's just be careful with our steps here just because there's a lot going on here with fractions and stuff. So multiplying these, we'd end up with -1/2 equals -2/5 plus b, like that. Then to isolate for this b value, you want to bring this over the -2/5 over, so we'd have -1/2 plus 2/5. And then over here, common denominator between 2 and 5 is 10. So we can multiply this by 5, multiply this by 5, multiply this by 2, multiply this by 2. So the b value would end up being -5/10, which is the same as 1/2, or -1/2, plus 4/10. So this would end up being -1/10, like that, right? Yeah, it looks correct to me. So the equation of this right bisector ends up being what? Y equals 2/5x minus 1/10, like that. Okay, so we have the equations of both right bisectors. And so from here, we just have to find the point of intersection between these two lines over here. So multiple ways to do it. There's a lot of fractions going on here. So at some point, I'm probably going to get rid of the fractions. You can get rid of them here if you want. So you can multiply everything by 2 over here. Here, the lowest common denominator would be 10. You can multiply everything by 10, right? And then you would have two equations. That would be all in terms of integers. So that's one way to go about it. And yeah, you know what? Let's do that. Let's first convert these to be all integers. Another way you could do it is you can just make them both equal. Like that, right? And then solve for x is just you're going to be dealing with lots of fractions here. If you want to maybe practice your algebra, so we can do it the way that I'm going to do it, get a certain answer, and then if you want to pause the video, come back to this and just practice some algebra, make sure you're getting that same x value that we're ultimately going to get. But what I'm going to do is I'm going to get rid of the fractions at this point. So I'm going to multiply everything by 2 here. So I'm going to multiply the y by 2, this expression by 2, then this expression by 2. So we'd end up with 2y. These 2's cancel out, so we'd end up with -x. These 2's cancel out, so we'd end up with just a 1 right there. Okay, so this, which is a line, 2y equals -x plus 1 is the same as y equals -1/2x plus 1/2. Then over here, to get rid of these fractions, I'm going to multiply the lowest common denominator between 1, 5, and 10 is 10. So we've got to multiply everything on the left side and the right side by 10. Multiply this by 10. So notice 10 times y would give us 10y. And then we'll have 5 goes into 10 twice. 2 times 2 is 4. 4x. These 10's cancel out, so we'll have -1, like that. Okay, and then if you want to check these, just a quick check, what you can do is you can just divide everything by 10, make sure that you get that. Notice when you do divide by 10, 4/10 simplifies to 2/5, and then we'll have that -1/10. Right, same thing here, divide by 2, we'd end up with -1/2, divide this by 2, we end up with that 1/2. Okay, so these lines are the exact same thing as those lines. And then I feel like finding the point of intersection between these is now a little bit easier, especially notice the x, it's already isolated, there's no coefficient in front, or there's a -1 in front. So what we could do is we could bring it over, bring the 2y over, so we'd have x equals 1 minus 2y. And then I'm going to take this and plug it in for that x. Again, you don't have to go about it this way. That's just the way that I'm doing it. Whichever way you do it, whichever way you're finding the point of intersection between these two, just make sure you're getting the same answer. All right, so I'm doing substitution. Let me just make sure that my steps here are all good. Yeah, it looks fine to me. So we'll have 10y equals 4 minus 8y minus 1. Bring this over. We'll have 10y plus 8y, which would give us 18y. 4 minus 1 gives us 3. Divide by 18. 3 over 18 simplifies to 1 over 6. So the y value ends up being 1 over 6. That's going to be the y value of the circumcenter. And then to get the corresponding x value, I feel like it's easiest to plug in over here. So we'd end up with x equaling 1 minus 2 times the y value of 1 over 6, which would be 1 minus, this would be like 2 over 6, which would be like 1 minus 1 over 3, which would give us 2 over 3. Or if you want to show your work, the 1 we could convert to 3 over 3 minus 1 over 3. That would be 2 over 3. So that's what the x value is. And so the coordinates of the circumcenter are 2 over 3 and then 1 over 6, like that. Right? And then again, if you want to confirm this, you could find the right bisector of AC. You can go through the exact same work we did, get the equation of that line, which is going to be in y equals mx plus b format. And then to confirm that it contains this point, you could just plug in 2 over 3 for x, 1 over 6 for y, and just make sure that the left side is equal to the right side. It's a good exercise for you to do and to just practice your algebra in finding these different kinds of lines. Now moving on to part C, we have to find the orthocenter, which is going to be the intersection of the altitudes, of all 3 altitudes of the triangle. And just as a quick review, what is an altitude? Well, an altitude, let's say we're finding it from this vertex, it's basically going to be the line that goes through this vertex where the slope of it is going to be perpendicular to the opposite side. Okay, you got to be careful. It's not the same as the right bisector. It's similar because of this perpendicular slope, but where can I show this? It's actually easier to show on one of these sides. Let's say that I'm finding the perpendicular bisector of this side over here. Well, what do? We find the midpoint. That's going to be the perpendicular bisector. But the altitude from here, it would be somewhere like, let's say over here, right, where this line is going to be perpendicular. So it's basically usually going to be going through a different point on that opposite side. So the process is different. We're going to be using, they're both going to have the same slope, the perpendicular bisector and the altitude, as long as the perpendicular bisector is on the opposite side of the vertex that you're drawing the altitude from. Okay, so they're going to have the same slope, but they're usually going to go through different points. Okay, so instead of going through the midpoint, like the right bisector was here, it's going to be going through point C. And because we actually already found those slopes, if you remember, in part B, the slope of AB was, what, 2? So that perpendicular slope was -1 over 2. And then the slope of BC here was -5 over 2, if I remember correctly. Yes, -5 over 2. And so that perpendicular slope was 2 over 5. So we can use those perpendicular slopes that we found in part B. We just have to make sure that the altitudes we draw, it's going to be from vertex C. So let me try to draw like that. Okay, so that looks good. So that's the altitude from vertex C. This altitude is going to have that slope, that perpendicular slope. And then we'd be working with this side, so we're going to draw the altitude from A. So it would look, let's say something like that, right? These are going to be perpendicular, like that. So the slope of that altitude is going to be positive 2 over 5, which we already found. Right? But if you didn't have those, it would be the same process. You'd have to find this slope and then find the perpendicular slope. And then you'd have that slope, you'd have the point, you could find the equation. Or if you're finding this altitude, you'd have to find this slope, find the perpendicular slope, you'd have the slope, you'd have the point, then you could find the equation. And then the point of intersection of them, that's going to be the orthocenter. And if you want to find the altitude from B as well, so it'll be like that, right? It's going to go through that same point right there. But we're not going to be finding that altitude. We're only going to be finding 2 of the 3 altitudes. And because we already have a lot of information from part B that we could use, we're going to find the altitudes from vertex A and from vertex C. So let's start off with finding the altitude. Let's start off from vertex A. So the altitude from vertex A. And what's nice is that, so we're finding this altitude here. We have the slope of it, which is 2 over 5. And we have the point it's going through, which is 8 and 4. Right, so one more time, notice the difference between the altitude and the perpendicular bisector of BC. When we found the perpendicular bisector of BC, we were using the same slope, but it was a different point. We were using the midpoint of BC here to find the equation. In this particular case, we're going to be using the point 8 and 4, which is the opposite vertex, right? Opposite to that side. Okay, so we'll have y equals, what, 2 over 5x plus b. And then we plug in for this, for x and y. So we'll have 4 equals 2 over 5 times 8 plus b. So this would be what, 16 over 5? This would be like 4 over 1 plus b. We could bring this over. So we'd end up with b equaling 4 over 1 minus 16 over 5. Multiply this by 5, multiply this by 5. So we'd have 20 over 5 minus 16 over 5, which would give us 4 over 5. Give me a sec here. Yeah, that looks right to me, right? 4 over 5. So this here would end up being 4 over 5 like that. So that ends up being the altitude from vertex A. So let's keep track of it over here. We got y equals 2 over 5x plus 4 over 5. We're going to use that to find the point of intersection between the 2 altitudes to get that orthocenter. So now let's find the orthocenter from vertex C. So we're going to find the equation of this line over here. So notice the slope of that line, negative 1 over 2. But instead of using the midpoint like we did for the perpendicular bisector, the point we're going to use is the vertex C, which is negative 4 and 7. So plugging this in, then we could plug in 7 for y, and then we could plug in negative 4 for x. 7 equals negative 1 over 2 times negative 4 would give us positive 2. Bring this over, so the b value would be 7 minus 2. Right? Or if you want to keep the b value on the right side as well, b would be 7 minus 2. It's just at this point I kind of just alternate these just to make it look nicer reading from left to right, but you could keep it like this as well, whichever way you do it. I don't want you getting confused thinking like I'm bringing this b value over and then I bring the 7 over, because then you'd have a negative b equals 2 minus 7, which would be negative 5. Then you got to divide both sides by negative 1. Right? I'm not bringing the b over, bringing the 7 over, I'm bringing the 2 over, but then I'm just kind of flipping both. Right? It doesn't matter which side of the equal sign you're on, so don't want you getting confused there. Okay, so the b value is it's 5 of that altitude here. So the equation of that altitude is y equals negative 1 over 2x plus 5, like that. Okay, so now what we got to do is we have to find the point of intersection between both of these lines over here. And so multiple ways to do it, substitution elimination. What I'm going to do is, like I did before, I'm going to get rid of the, actually, you know what, let's switch it up in this case. So let's just make both of them equal and then solve for x. So that's the way I'm going to do it in this case. But if you want to do it the other way, like I did before, you can multiply everything by 5 here. You'd end up with 5y equals 2x plus 4. You can multiply everything by 2 over here. You'd have 2y equals negative x plus 10, right? And then you could just work with those. These two lines are the same as these two. You can maybe isolate for that x, use substitution, right? I'm going to go over it the other way just in case that's the way that you usually do it and you want to get some practice with fractions, even though it is a little longer in my opinion to do. But whichever way you do it, just make sure you're getting the same intersection point that I'm going to get. So in this particular way, what we're going to do is bring the negative 1/2 x over, bring the 4 over 5 over. So we'll have 2 over 5x plus 1 over 2x. And this would be 5 minus 4 over 5. So let's work with these separately. 2 over 5 plus 1 over 2. Lowest common denominator is 10. Multiply by 2, multiply by 2, multiply by 5, multiply by 5. So we'd have 4 over 10 plus 5 over 10, which would give us 9 over 10. So over here, we'd end up with 9 over 10x. Then over here, this 5 is like over 1. So we'll have 5 over 1 minus 4 over 5. Multiply by 5, multiply by 5. 25 over 5 minus 4 over 5, which would give us 21 over 5, like that. Right? Yeah. So we'd have 21 over 5. And then from here, you can divide both sides by 9 over 10. I'm going to combine these into 1, just so we can smoothly now cross multiply. So we'll have 9x times 5, which would give us 45x, and then 21 times 10, which would give us 210, like that. Then we can divide both sides by 45, like that. So we'd have x equals 210 over 45, like that. And then we could definitely simplify this further. So we could definitely divide everything by 3, divide this by 3. That would give us, what, 70? We could divide this by 3, which would give us 15. And then we can divide further. We could divide this by 5, divide this by 5. So we'd end up with, what, 14 over 3? Right? We could have also divided this by 15, divided this by 15, like that, to get to that 14 over 3 quicker. So that there represents the x value of the orthocenter. So let's keep track of it over here. So we have the orthocenter. That's going to be at 14, 3. And then we need the corresponding y value. And to get the corresponding y value, we can plug it in either to this equation or this equation. Doesn't matter which one. I'm going to use this one over here. So we'll have y equals negative 1 over 2x plus 5. Let's plug in 14 over 3 for x. So just be careful with the algebra here. 2, 14, that can simplify to 7 over 1, right? 14 over 2 is like 7. Negative 1 times 7 gives us negative 7. 1 times 3 is 3. Plus 5. This is like over 1. Lowest common denominator between 3 and 1 is 3. So 3, 3. Negative 7 over 3 plus 15 over 3, which would give us 8 over 3. So that's the corresponding y value. That doesn't simplify any further. So the corresponding y value of the orthocenter is 8/3. So this point here where all three altitudes intersect is at 14/3 and 8/3. And again, if you want to find that altitude from B using this same process, right? Finding this slope of AC, getting the perpendicular slope, then finding the equation of the line that has that perpendicular slope and goes through 2, -8. Get that equation. It's going to be in y equals mx plus b form. Then you could plug in this, the orthocenter for the x and y, and just make sure that the left side is equaling the right side. All right, so we found all three of those points we were looking for, right? The centroid, which is, as a review, the intersection of the medians, the circumcenter, which is the intersection of the right or perpendicular bisectors, then the orthocenter, which is the intersection of the altitudes. Now what we have to do is we have to, for part D, show that they are collinear. Okay, so if I graph these points, now this is not going to be to, actually, you know what? Let's just make it to scale. Why not? So 2/3, 1/6. Let's say that's going to be like over here, right? Then 2 and 1, that's going to be like over here. Then 14/3, 8/3, that's going to be like over here, right? Generally, that's how it's going to look, right? The lowest x value is the 2/3, the second lowest is the 2, and then the highest x value is the 14/3. And then we have the lowest y value, which is 1/6, second lowest, which is 1, and then the highest y value, which is the 8/3. Right, so that's approximately how it's going to be, and we got to show that these points here, that they are going to be collinear. Right, so how do we do that? How can we show that they're collinear? Well, what we can do is we can just take 2 of the 3 points, right? I'm probably going to use these 2 points over here. So what I'm going to do is I'm going to take these 2 points. I'm going to find the equation of the line between those 2 points. We're going to get some kind of equation, which is going to be y equals mx plus b. And then all we have to do is confirm that this point, this third point, lies on this same line. And the way we can do that is plugging in, once we have this line, it's going to be y equals something x plus something for the b value. We could plug in the x, plug in the y, and just make sure that the left side is equal to the right side. And if that happens, we confirm that this point lies on that same line. Another way to do it is you can actually find the line between these 2 points, and then you could find the line between another 2 set of points, including this one. So let's say you find the line between these 2 points. What you'll notice is that that line is going to be the same. Or you could find the line between this point and this point as well. Right? So you could find 3 different lines, no matter which points, which 2 of the 3 points you're using to find the line, you're going to get the same line. So you could find the line between these 2, and then once you have that line, you can confirm that that point is going to be on that same line. Right? So that's another way to do it. So multiple ways to show that they're collinear. But as I mentioned, what I'm going to do is I'm first going to find the line between 2 and 1 and 2/3 and 1/6. And remember, this line that we're finding here, it's called the Euler line. So what we're first going to do is we're going to find the slope between these 2 points, which is y2 minus y1 over x2 minus x1. So I'm going to label this x2, y2. It doesn't matter which ones you label what, but I'm going to label it like this. So we'll have y2 minus y1, so we'll have 1 minus 1/6 over x2 minus x1, like that. Yeah, it looks all good to me. So now, because we're working with fractions within a fraction, let's work with both the numerator and the denominator separately, just to not get too much commotion in one part of the work. So this 1 is like over 1. We could change that to be 6 over 6 minus 1 over 6, which would give us 5 over 6. So this numerator ends up being 5 over 6. What about the denominator? So we'll have 2 minus 2 over 3. It's like 2 over 1, multiply by 3 to get a lowest common denominator of 3. 6 over 3 minus 2 over 3, which would give us 4 over 3, like that. That's what the denominator simplifies to. So we end up having 5 over 6 divided by 4 over 3, divided by 4 over 3. I like to rewrite it like that, which would be like 5 over 6 times 3 over 4, like that. And then you can multiply these. You get 15 over 24. Another thing you could do is you could see that the 3 goes into the 6 twice, but if we did it like this, we could just simplify this, divide this by 3, divide this by 3, we end up with 5 over 8. Right? But if you took the 3, put it into the 6 twice, 5 times 1 is 5, 2 times 4 is 8. All right, so the slope between these 2 points is 5 over 8. So we'd end up with y equals 5 over 8x plus b. Now we have to solve for the b value. We could plug in this point or this point. I'm going to plug in this one just because there's less going on. So we got y, which is 1, and then we're going to plug in 2 for x, like that. So this would end up being 10 over 8, which would be 5 over 4, like that, right? And then we bring the 5 over 4 over, so we'd end up with 1 minus 5 over 4, which is the b value. This one we could change to 4 over 4, which would give us negative 1 over 4. So that ends up being the b value. This ends up being negative 1 over 4. Okay, so that is the line going through the centroid and the circumcenter, right? So this here, as I mentioned, let me just write it. It's called the Euler line, if you want to look that up. It's basically the line that's going through all 3 of these points. So we know that between these 2 points, this is the equation of the line. So all we have to do is confirm. To confirm that these are collinear, we just have to confirm that this point lies on this line over here. And the way we can do that is we can just plug in 4 over 3 for the x value. Or sorry, not 4 over 3, 14 over 3 for the x value. And whatever we get here, we just have to make sure that that corresponding y value ends up being 8 over 3. And if it does end up being 8 over 3, then we confirm that this point lies on this line over here. Okay, so to do that, notice that the 14 over 8, that simplifies to 7 over 4. Then we'll have 5 times 7, which is 35, 4 times 3, which is 12, minus 1 over 4. What's the lowest common denominator between 12 and 4? It's 12, so we can multiply this by 3, multiply this by 3, right? So we'd end up having 35 over 12 minus 3 over 12, which would give us 35 minus 3 is 32, 32 over 12. And then notice we can divide this by 4, divide this by 4 to simplify it. What does it simplify to? It simplifies to 8 over 3 as expected. And so because we got that 8 over 3, we confirm that this point lies on this line over here. Or if you plugged in the 8 over 3 here and did all the algebra, you'd get the left side equaling the right side. If this was an 8 over 3, then there was something wrong, right? Then you got to go back and check your steps. But luckily we got the 8 over 3, so we confirm this point is on the line that we found between those 2 points. And so we just showed that they're all collinear. And again, you could find the equation of the line between these 2 points. You could find the equation of the line between these 2 points. You're going to always get that same line. So it's kind of cool how that works out. Right? So lots of algebra, lots going on in this video. But again, I wanted to put these 3 points into one triangle to show you that they're all collinear all the time for no matter what triangle you're using. Right? So that's the process for finding the centroid, circumcenter, the orthocentre, and then showing that all 3 are collinear.